Buonasera a tutte e a tutti. Buonasera alla candidata, la dottoressa Ester Sudano, collegata da remoto. Buonasera alla commissione qui presente, costituita dal professor Alfio Giarlotta, Università degli Studi di Catania, Dipartimento di Economia e Impresa, che ringraziamo per la sua presenza nella veste di relatore della tesi di diploma della dottoressa Sudano, e la professoressa Silvia Angilella, Università degli Studi di Catania, Dipartimento di Economia e Impresa, che interviene come componente della commissione di questa sera nella veste di opponent, di controrelatrice. Sono qui nella veste di presidente e di coordinatrice di classe della classe di Scienze umanistiche e sociali della Scuola Superiore di Catania e porto ai presenti, al pubblico qui in aula e da remoto, i saluti del presidente della Scuola Superiore di Catania, il professor Daniele Malfitana, e del collega coordinatore della classe scientifica, professor Angilella. Prima di iniziare domando ad Ester se desidera presentare in inglese o in italiano, avendo margine di assoluta libertà nella scelta della lingua.
Salve a tutti, grazie. Io preferisco presentare in inglese.
Perfetto.
Concordo.
Allora avremo... Prego, professore.
No, concordo nella scelta di Ester. Non è stata concordata, ma concordo nella sua scelta.
Benissimo. Procediamo dunque a presentare la candidata Ester Sudano, allieva diplomanda della Scuola Superiore di Catania nella classe di Scienze Umanistiche e Sociali. Il corso di studio è quello di Finanza aziendale. La dottoressa Sudano ha sperimentato una brillante carriera accademica nell'Università di Catania nel Dipartimento di Economia e Impresa, con una eccellente media curriculare, ed è stata ugualmente una allieva di grandi qualità accademiche e umane dentro la scuola superiore qui a Villa San Saverio. Il suo percorso post laurea testimonia la bravura, l'intelligenza e l'impegno della dottoressa Sudano, che oggi è qui per presentare e discutere una tesi di licenza magistrale dal titolo Rationality and resolvability in choice. La dottoressa avrà dunque 20 minuti per la sua presentazione. Potrà iniziare dopo l'introduzione del tema e della candidata, che sarà condotta dal professor Giarlotta, al quale cedo subito lo schermo.
Grazie tante. Innanzitutto buon pomeriggio a tutti. Allora, io Ester la chiamerò di nome perché mi sono abituato così, niente formalismi con lei, quindi dottoressa Sudano diventa Ester. Allora, Ester, diciamo, facciamo una presentazione di carattere generale e poi andiamo subito nel dettaglio. Ester, devo dire, è caratterizzata da grande serietà, a volte fin troppa, direi, che l'ha portata a sviluppare questo argomento di ricerca in modo sistematico. Un'osservazione preliminare che faccio subito è che il lavoro che ha fatto, che tra l'altro lei sta attualmente sviluppando in molti dettagli nel suo corso di dottorato, è un lavoro difficile ma anche interessante. Molto spesso le cose difficili non sono interessanti e le cose interessanti non sono difficili. In questo caso c'è intersezione non vuota, le cose sono interessanti e sicuramente, mettiamola così, non facili. Perché? Perché si tratta di manipolare strumenti che sono economicamente significativi, ma anche all'avanguardia della letteratura in teoria della scelta. Quindi combinare questi strumenti in modo semanticamente opportuno è una cosa non banale. Allora, fatemi un po' presentare rapidamente l'oggetto del contendere. In questo elaborato Ester descrive una nuova nozione di risoluzione di scelte. La risoluzione di scelte è stata introdotta recentemente in letteratura più o meno 2 anni fa, e l'idea base di questa nozione è quella della decomposizione di un processo di scelta in unità operative che sono però tra loro indipendenti. Questa nozione è estremamente potente perché consente di spiegare comportamenti di scelta che altrimenti potrebbero risultare alquanto oscuri o ambigui. Il contributo della dottoranda è quello di mettere questo strumento in relazione con le scelte stocastiche, in particolare con un modello recentissimo del 2022, anche se la sua analisi ovviamente si estende a modelli più classici, con un paper recentissimo di Kovac e un'altra persona il cui nome ho smesso di pronunciare tanto tempo fa perché risulta assolutamente impossibile. Serezmid, sarà lei a pronunciarlo meglio. L'idea è quello di diciamo generalizzare un tipo di approccio che già di suo era una generalizzazione di un approccio noto in letteratura che modellizza un fenomeno chiamato effetto di similarità. Allora, questa nozione di scelta stocastica risolvibile rappresenta essenzialmente un processo di scelta in cui il decisore, l'agente economico, in prima istanza classifica nel processo di scelta, classifica tutte le alternative disponibili in categorie. Dopo, in una seconda fase, sceglie una categoria tra queste disponibili e, terzo e ultimo stadio, seleziona un'alternativa che appartiene a tale categoria. Quindi questo processo di scelta innanzitutto è quella che si chiama tecnicamente in teoria della scelta una choice function, ovvero sia una funzione che da ogni menu, ove menu è un insieme di alternative arbitrario, sceglie uno e un solo elemento. E diciamo in questo modello si attinge, devo dire ampiamente, alla letteratura esistente su scelte con categorizzazione. E l'idea è quella di rilassare le assunzioni di razionalità normalmente richieste, che molto spesso non sono delle assunzioni, diciamo, realistiche, sono troppo restrittive. E senza scendere nel dettaglio, perché sarà sicuramente Ester a farlo, mi limito a osservare che questa scelta, questa tesi si colloca in una posizione di continuità rispetto a alcuni articoli di recentissima pubblicazione, quindi è estremamente aggiornata, ma soprattutto modellizza in un modo a mio avviso economicamente significativo un processo economico di scelta di un decisore. A parte questo, ci sono tanti problemi che rimangono aperti, sicuramente interessanti. Vedere, per esempio, estendere questo modello a quelle che si chiamano corrispondenze di scelta, in cui il decisore non è costretto a scegliere un solo elemento da ogni menu, ma ne può scegliere più di uno. Addirittura, in casi estremi, nessuno. E quella sarebbe una quasi scelta. Ma soprattutto, in una direzione che oramai è diventata di moda, forse sarebbe il caso di formulare un test econometrico in modo tale da poter applicare questo modello a dati effettivi di scelta. Se questo si riuscisse a fare, ma non ne conosco onestamente la difficoltà, perché ci vuole a tal proposito un esperto di statistica o comunque un esperto di econometria, se questo venisse fatto, a mio avviso questo tipo di analisi, questo modello e tutte le sue derivazioni successive sarebbe passibile di pubblicazione su uno dei giornali top 5 in economia. Colché ritengo di concludere la mia presentazione, che è stata assolutamente generica, ma non volevo entrare nel dettaglio, perché preferisco lasciare a Ester il piacere, dovere, onere, chiamiamolo come vogliamo, di farlo. Grazie.
Prego, Ester.
Sì, io vorrei condividere lo schermo, ma non riesco in questo
Provvediamo
momento.
subito, sì.
Grazie. Grazie.
Benissimo.
Ok, dovrei esserci. Ok, thank you, first of all. This work of thesis deals with the notions of rationality and resolvability in choice. We focus on rationality because rational choice is fundamental in macroeconomic theory. It is indeed, it can be thought of as an attribute of the agent that allows economic analysts to talk about the agent as a utility maximizer. And from the point of view of an external observer, rationality in choice means that by observing choice, the observer is able to find a consistent motivation. And that consistent motivation usually takes the form of the agent is choosing the best in some sense. From another point of view, it is well documented in psychology that the agents usually don't evaluate all items at once, but apply sequential choices, multi-step choices. And that's why in literature, these kind of choices have been, these kind of choice models have been introduced in various ways. We focus in particular on the notion of resolvability as introduced by Cantone, Giarlotta, and Watson in a deterministic setting. And what we study is the relation between rationality and sequentiality. We study that not only in a deterministic setting, which is the analysis that was performed by Cantone, Giarlotta, and Watson, but also in a stochastic environment. And that's why the main contribution of this work is the definition of resolvability in stochastic choice and the analysis of how it relates to rationality. So we start in a deterministic setting, and given a set of items X, we call menus all its finite non-empty subsets. And to represent a choice, we use a function that associates to each menu that is offered to the agent the subset of the items that are selected by the agent. If the agent only chooses one item per time, this is a choice function. When an external observer observes these choices, he may wonder what is the motivation that underlies them, and whether one can find a motivation in terms of preferences or taste. So in a natural way, it has been defined in literature, the concept of preference revealed by the choice. And X, an item X, is revealed preferred to Y if there exists a menu in which both X and Y are present and the agent is choosing X. In other words, X is revealed preferred to Y if there is a menu in which such preference is witnessed. And in this way, one can find out a way to infer a taste, the taste or preference of the agent, given the choices that are observable, as the taste and the preferences are usually unknown for a researcher. So a choice is rationalizable if the preference that is revealed by the agent allows to say that the choice is actually the result of some maximization criterion. So the preference that is revealed by the agent is actually all we need to know to understand why the agent is making such choices. Not all choices are rationalizable. These are the two axioms of consistency that are required for a choice to be rationalizable. In particular, if an item is chosen in a menu, it should be chosen in a smaller menu when there is less competition. And in a symmetric way, I would say, if an item is chosen in each menu in a collection, it should be chosen in the union of all these menus. So if the choice satisfies these two axioms, we can say that the choice is rationalizable. And actually, the agent is maximizing her preference when choosing. And as you can see, there is okay. Sorry. Okay. Okay. Anyways, as you can see, at this point, the choice is when I say that the choice is rational, sorry, when I say that the choice is rationalizable, I'm not analyzing the choice procedure that leads to this result. I'm only analyzing the way, the degree of consistency that could allow to relate the choice behavior to some underlying taste or preference. Now, about the choice procedure. I will introduce the deterministic resolvability with a slightly different notation than the one introduced by Cantone, Giarlotta, and Watson, which is anyway equivalent. Now, this is an example of a choice that is a two-step choice. And in particular, given a choice C on a set Z, it is horizontally resolvable if there exists a partition of the set of items induced by a projection map that assigns each item to the subset in the partition to which it belongs. Then there is a base choice defined on these indices, and a family of fiber choices, each defined on a set in the partition. Then the choice, as I was saying, is resolvable, horizontally resolvable, if it is the result of the following procedure. First, given any menu A, the agent understands A and looks at A as a collection of indices, you can think about them as categories, and performs a choice over these categories. If category little I is chosen, then the agent focuses on the items in A that belong to that category and chooses something according to the fiber choice. The union of all these choices is the final selection that is made. So, as I was saying, you can interpret easily, intuitively, this definition as a choice by categorization, but in a more technical and general way, this is to say that the choice that one observes, the full choice, can be actually explained as the composition of smaller, in a way, independent choices. And this means that each of these choices can be studied independently and can give richer information on how the agent classifies items. So the authors characterize resolvable choices, and in particular, these are characterized by the presence of a shrinkable set. A shrinkable set is a set E that for which the choice satisfies these properties, which all boil down to say that all the items in E have the same relationship to all the items that are outside of the set. I won't have time to spend to say more about this, but suffice it to say that a choice is resolvable if and only if there is a shrinkable menu of at least two items. Now, the question is, if a choice is resolvable, is it rational or vice versa? And the authors find that resolvability and rationalizability are independent notions, and but they are related by this theorem that says that if a resolvable choice is rationalizable, if and only if both its base and its fibers are rationalizable. That is to say that the agent could apply a sequential procedure, and he will appear rational if he is rational at this stage of the procedure. So that the procedure of choice doesn't really interfere with the outcome that is rationality, if that is the case. Similar results hold for other items of consistency, but I think it's time to move to the stochastic setting to perform the same kind of analysis. The stochastic choices have been introduced because usually the agents display some variability in choice. Given the same menu more than once, the agent may vary their selection. So given a finite set of items, X, and the collection of its non-empty subsets, a stochastic choice is a map that assigns a probability to the event that an item is chosen from a menu. if the item is not in the menu, the probability it is chosen must be 0. And since we assume that all the items are mutually exclusive and something must be chosen from any menu, the summation must add up to 1. If for all menus, every item has a positive, strictly positive probability of being chosen, we say that P is positive. So, as I was saying, a stochastic choice P can be interpreted as the frequency in repeated choices performed by the same individual, or as occurrences in a population, but we will stick to the first interpretation, which is better suited to our interpretation. So, a notion of rationality has been introduced into stochastic choice. Given P defined on X, we also look at the set of linear orders defined on X. Linear orders are binary relations that are transitive, antisymmetric, and complete. So you can think of them as rankings of the items in X that admit no ties. We said that a choice is rationalizable by random utility maximization if there exists a probability distribution on the set of linear orders, such that the probability that an item is chosen in a menu equals the probability attached to the set of linear orders for which A is the maximum element. So through this probability distribution P, one can represent the variability in taste or in states of the world. And depending on the taste or the states of the world, the agent may pick a different preference. That could be, for instance, depending on their mood. And the probability an item is chosen is the probability that a linear order that is maximized that item is picked. And in this case as well, we are not actually investigating what is the choice process, the choice procedure that leads to P. We are simply stating what property ensures that the agent is still a maximizer. So we now introduce the notion of resolvability in stochastic choice that mirrors the one in the deterministic setting. And we say that P is resolvable if there is a partition in classes, still induced by a map that represents classification in a way. There is positive stochastic choice defined on the indices and a family of positive choices, each defined in a set in the partition. Think about this as a categorization process. You can interpret this definition in the following way. The probability that an item little a is chosen in the menu is equal to the probability that the category to which it belongs is chosen among all the available categories. And this is the first step of the selection. Given that the agent is choosing item I, the agent will look at this intersection and choose something that belongs to that category. So again, one could interpret P as the result of a categorization process, but more in general, one could simply say that P is the result of the composition of independent stochastic choices. And if you look, this is an example of a resolvable stochastic choice. This example, I won't dwell on details, but this choice violates all the axioms of rationality that have been introduced in literature. Still, some pattern could be found. So, for instance, every time X is present, X is chosen with a probability of 3 out of 8. And every time X is added to a menu, X doesn't change the probability, the relative preference for other items. For instance, C is chosen twice the times than B here, meaning that C is relatively preferred to B. And the same relative preference can be found in this menu. So actually, even though one could not analyze this choice from a rationality point of view, it could still be analyzed in terms of finding what are the categories, for instance. This could be the case that X is a vegetarian dish and A, B, and C are meat dishes. So that the presence of X doesn't really change how an agent prefers one meat dish over another, since these two sets are distinct and do not interact in the mind of the decision maker. So we want to find out when we can say that a choice is resolvable. This happens when the choice satisfies two axioms. The first, independence of external alternatives, is the one I was describing briefly before. Given two items A and B that belong to the same category, let's interpret a reducible set as a category. If A and B belong to the same category, the addition of any external item is not going to affect the relative preference, which is expressed by this ratio. Also, we require that that for any external item, it doesn't matter what are the items in another category that are available, because the items in the same category are going to be substitutes. So the amount or the identity of these items is not going to affect the probability that X is chosen. It doesn't matter how many meat dishes are available in the menu. If I want to eat vegetarian, that only depends on what other vegetarian dishes are available. And we say that reducible set is non-trivial if their cardinality is between 1 and X. That is to say, it's not a singleton or it's not the whole set X, which are trivially categories, reducible sets. Sorry. So the presence of a reducible set characterizes resolvability. And once the reducible sets are found, one could partition X in classes. So one could really uncover these categories, if that is the interpretation. And reducible sets can be nested, intersecting, or disjoint. There are no constraints in the structure. And that means that P can be resolvable with respect to more than one partition. And this actually allows to represent the event that one item belongs to more than one category at once, which is quite realistic. And of course, the independent choices omega and sigmas can be retrieved from the observable probabilities P. So an important result is that resolvability does not interfere or relate strictly to rationalizability, just as happened with in a deterministic setting. Though, just like it happens in a deterministic setting, a resolvable stochastic choice is rationalizable if and only if all the choices that compose it are rationalizable. So again, even in a stochastic environment, if the agent is rational at all the stages of the choice, he will appear rational when the full choice is considered, and vice versa. This is this is a summary of the most important results. And to conclude, we've seen that resolvability, both in a deterministic and in a stochastic setting, allows to break the choice down into independent subchoices that can be studied independently. This model can be interpreted in a behavioral way as the result of categorization. And especially in the case of stochastic choices, applying these properties to choice data can allow to uncover categories, which is, I believe, an interesting stream of research. Other results relate to a generalization of the model that allows stronger menu dependence in choices. And also, the more general model relates in a natural way to loose model and to nested logit, which are prominent models in stochastic choice and in discrete choice. Further directions of research include the investigation of what is the population that generates these choices, which is quite usual and unusual analysis for stochastic choices. And as Giarlotta already mentioned, Professor Giarlotta already mentioned, the application to choice data would be an interesting path. That's all.